In this section, we're going to find missing trig sides. So what it means is that you have one unknown side and one given side with a given angle. Now, unlike the last section, you had angle theta, but now you actually have a number for our angle, in this case 61 degrees. So in this first example, we're going to try and find side M. Now, when it comes to trig, you would need to use a calculator, but here the main focus is to set up the work, because once you set up the work correctly, then simply typing into your calculator will only take us a few seconds. So the main focus of this video is trying to set up when trying to find missing trig sides. So first, we're going to have to label our sides. So we're going to start off with the right angle. What's across is the side, which is known as the hypotenuse. And then looking at the 61 degrees, if we were to compare it with the side 14, so this side is across 61 degrees, so that means 14 is the opposite side. So again, when we're working with example like this, finding missing trig side, first identify your hypotenuse across from the right angle, and then compare the sides with the given angle, 61 degrees. So now we have to identify which trig function, sine, cosine, or tangent that use opposite and hypotenuse. Looking at this, the only one that has O and H is sine. So we're going to set up sine. So I'm going to write sine right here. Theta equal opposite over hypotenuse. Okay, so that's how it generally set up. Now, in theta, that's where we put the angle measure, 61 degrees. We plug in for opposite, which will be 14, and you're going to plug in for hypotenuse, which is M. So I'm going to write right here, sine of 61 degrees equal, my opposite is 14, over my hypotenuse, which is M. Alright, so when we're trying to solve for M, that means you're trying to get M by itself. So the first thing we're going to do, since M is in the denominator and it's a fraction, so this is a fraction meaning it's a division. What's opposite is multiplication. So I'm going to multiply both sides by M. So when I do that, on the left side it's going to be M sine of 61 degrees equal, and on the right side, when you have something like this, a fraction times a whole number, M divided by M will become 1. 1 times 14 will be 14. Alright, I'm almost done. Again, I want to get M by itself. Right now it's M sine 61 degrees. So it means M times 61 degrees. So all I'm going to do is just divide by sine of 61 degrees, and then divide on the right side sine 61 degrees. So on the left side it will be M equal 14 over sine 61 degrees. And that will be our final answer, because I was able to get M by itself. So M equals 14 over sine of 61 degrees. So that's all you have to do. Just use basic algebraic skills. Try and get the variable by itself. Here we have our second example. In this given triangle, we have a side that's 23. We have a side that is x, so that's going to be our unknown variable. we have a given angle, which is 49 degrees here with a right angle. Now, the first thing, just like the last example, identify your hypotenuse. So the side that's across from the right angle will be our hypotenuse. And then according to this angle, so this angle here and this side x, it's next to it, so this will be adjacent. Alright, so for adjacent and hypotenuse, looking up here, the one that use a and h, the only of the three trig function is cosine. So let's do the setup. Now it's cosine theta equal a over h, adjacent over hypotenuse. Alright, so all I'm doing is going to plug in theta with 49 degrees, plug in adjacent with x, and then plug in 23 for hypotenuse. So we're going to have cosine of 49 degrees equal, my adjacent is x, my hypotenuse is 23. Alright, so from there, I want to get x by itself, but it has a 23 in the denominator. So if I want to get rid of it, what's opposite of dividing, because it's a fraction, I'm going to multiply by the denominator. So 23 on the right side, therefore I'm going to multiply by 23 on the left side. So on the left side, it will be 23 times cosine of 49 degrees equal, on the right side, 23 divided by 23 will be 1. 1 times x is just x. So I got x by itself. I'm just going to flip it. So x equals 23 times cosine of 49 degrees. So that's all we have to do. Since I got x by itself, this is our final answer. X equal 23 times cosine of 49 degrees. In this section, this example, we have a triangle with two given angles, one unknown side and one given side. So with this, our first job is identify the hypotenuse. So here, this is the side across opposite of the right angle, so this will be hypotenuse. Now, when you're given two known angles, you have to pick which one to use if you're trying to solve for your unknown side. The reason you have to pick is because when you pick one, you have to label your sides. So if I were to do the 26, the side that's across from the 26 is opposite, and then the side that's next to it is adjacent. So that's if I choose to use the 26. But if I choose to use the 64, doesn't matter which one you use as long as you set it up correctly. So say I use the 64. What's across from the 64 is the W, so I'm going to write opposite. And then what's next to the 64 is the adjacent. So be mindful of the colors that I use. So if I use a 64, my 37 is adjacent and my W is opposite. If I were to use a 26, my 37 is the opposite and my W is the adjacent. So in this example, It doesn't matter which angle you can use any one you like. But I'm going to do example for both of them. Alright, so say I decided to use the 26. Now, of the trig function, sine, cosine, and tangent, for my 26, I have two sides, opposite and adjacent. So the only one that has an O and an A is tangent. So tangent, I'm going to set it right here. Tangent theta is equal to opposite over adjacent. So all I'm going to do is plug it in. So it's going to be tangent of 26 degrees, because I'm using the 26, is equal to my opposite, which is 37, over my adjacent, which is W. So next, what I'm going to do is I'm going to multiply both sides by W, because I want to get rid of fraction. So when I do that, I'm going to have W tangent of 26 degrees equal to 37. And then after that, I want to get W by itself. So I'm going to divide the left side by tangent of 26 degrees. And then divide the right side by tangent of 26 degrees. So W will equal to 37 over tangent of 26 degrees. So that would be the final answer if I were to use 26 degrees. Now, if I chose 64 degrees, which is fine, I'm still going to set it up here. Now, the 64 degrees, it still use adjacent and opposite, so I'm going to be using the same function, tangent, because OA. So I'm going to set it up right here. So tangent theta is equal to opposite over adjacent. So I'm just going to plug in for theta, plug in for opposite, plug in for adjacent. So it's going to be tangent of 64 degrees equal my opposite will be W. My adjacent will be 37. Alright, so from there, I want to get W by itself, but I have a 37 in the denominator as a fraction. So I'm going to multiply both sides by the denominator. So on the left side, it will be just 37 tangent of 64 degrees equal to, on the right side, 37 divided by 37 is 1. 1 times W is just W. Since I get W by itself, I'm going to flip. So it's going to be W equal to tangent of 64 degrees. Sorry, I'm missing something. 37 times tangent of 64 degrees. So that's going to be our final answer because I was able to get W by itself. Now, if we were to compare these two answers, this W is equal to 37 times tangent of 64 degrees. The second one right here, W is equal to 37 over tangent of 26 degrees. The reason it looks different is based on what angle you use and the relationship of its sides. So again, if I were to use 64 degrees, W is opposite and 37 is the adjacent. Had I used 26, 37 is opposite, W is adjacent. So as you can see here on how I set it up, either using the 26 degrees or the 64 degrees, and then work it out to get W by itself, it looks different, but if you plug this in the calculator, you will get the same answer. So for this example, even though we use tangent twice, because both angle we're using opposite and adjacent, we got different form. So in the end, it doesn't matter which one you use as long as you set it up correctly. So I repeat, doesn't matter which one you use as long as you set it up correctly.